Okay, so now my main duty today, or maybe secondary duty, and of course it's all downhill after that, right? Is to introduce our speakers. First is Michael Heroux. He's a senior scientist at Sandia National Laboratories and also a scientist in residence at St. John's University in Minnesota. Dr. Heroux leads development of the Trillinos project, an effort to provide reusable parallel scientific and engineering software. Also the Mantivo project, which focuses on open source, portable mini applications for scientific and engineering applications, and the IDEAS Scientific Software Productivity R&D project. He also leads development of the HPCG benchmark, which is intended as an alternative ranking for the top 500 computer systems, and it's a rising benchmark in the HPC world. He has been involved in community efforts to improve reproducibility of scientific results, software quality, and professional recognition for CSE software contributions. Dr. Heroux.
Good morning, everyone. Thank you for the invitation to come and speak with you today and share some ideas, and hopefully some of this will be meaningful to you as we go along. A bit of an outline. First, I want to give you my perspective on this. I'm not a professional software engineer, and so I want to tell you what I think I am. Then I'll talk about some concepts and definitions and why I care about productivity and sustainability. And then I'm going to give some incentives for why I think you should care about it. And then talk about a completeness philosophy, which I think is a really good guiding principle for us as we go forward. And then try to give you some practical strategies. And then finally, to give you some ways to participate in what we're trying to do. So what is my perspective? I think of myself more as a psychologist who grew up in a messed up family and went into the field to try to fix their personal life. I have been in the scientific software business for about 30 years, and I've written good software and bad software. And I've seen good software written and bad software written, and you don't get to see the full impact of good and bad until a decade or more later. And so I'm that kind of person, right? So I don't come to you as a professionally trained software engineer. I come to you as someone who's done a lot of this work and observed a lot of this work, and I want to improve it and help improve your lives as we go forward. Similarly, I'm not an engineer. I'm not a software engineer in this way. I'm a carpenter. I use the tools that people provide to write software, and I love these tools, and I hate some of the tools, and I come at it from that perspective as well. So this is when I tell you the things I'm going to say in the next 2 hours, right? Is it 2 hours? No. Okay. In the next 30 minutes or so, I'm going to come at you from these two perspectives. Before we get started, though, let's talk about some terms that I think are fuzzy for some people. They certainly were for me when I started getting involved in this field. And let's look at productivity and sustainability. Okay, so very simply, productivity is output per unit input. It's not fancy, right? You get something out for what you put in, and you can measure that as a ratio, and that's essentially our definition. So just think about it from that point of view, a very simple formula. Sustainability, maybe a little bit more nuanced, to me is the future cost of usability. If I can make something more sustainable today, that means I've reduced the cost, I've increased the ability that I'm going to use that software or that product in the future and not throw it away because it's just too hard to maintain it. And so those are two critical concepts in our discussion today. The other thing that I think is really important is I want to focus on improvement, incremental improvement. I don't want to get into complicated, detailed formulas to measure the exact productivity or the exact sustainability. I want to use a much more practical approach, what I call the optometrist approach. You go to the eye doctor, and the eye doctor puts this thing up to your face and flips a lens and says, is this better or is this better? Okay, at that level, even in a very complicated situation, I can modify a little bit of my environment and see, is it better? If I were to change something the way I do my work, a small thing, is that going to make my life better? And so I'm not after the big picture, massive productivity metric and improvement. I'm after the small scale stuff that we can do, because there's a lot we can do there. And we can get insight into the big scale stuff as well. By doing that approach. All right, so let's start off with a scenario. Okay, I want to get your heads in the way I'm trying to think about things. So here's a scenario. Okay, this could be you, right? Right now, you are working on things. You have projects that you're working on, right? So let's say you're behind in developing a sophisticated new model. It could be a mathematical model for a climate simulation. It could be a new algorithm to partition graphs. It could be anything, whatever you're working on. Think about a problem you're working on, and you're behind, right? Which happens, right? It just happens. And so you need to get a result for a paper. Okay, so this is your situation. What choices do you have to make? Well, you can develop a simpler model. Take out some of the features, right? And maybe you'll get done on time. You won't lose a lot of extra sleep. You'll get that paper submitted. Fine, life is okay. It's not the best result you could have gotten, but you got something in. Another one is you could set other work aside, right? You could reduce the amount of little sleep that you already get and work more on it and get it done, right? So that's another approach. And a third is to ask for an extension on the paper deadline. So, and you can combine those in various ways, right? But those are your three basic axes that you can pick. And so we talk about better, faster, cheaper, pick two of the three. This is the kind of choice that we make on a regular basis, okay? I'm going to offer two other approaches that you could try. I'm not suggesting them, but you could try because I know they happen. Okay? You could develop that sophisticated model, but don't test it. Okay? Don't make sure it's right. Right? Submit the paper anyway. Okay, high risk, perhaps, but it's an approach that people try. You could develop a sophisticated model, but then don't document it and don't check it in. So in other words, it just dies off in some subdirectory of your repository, and you may never get back to it. And so these are choices people make. And what I'd like to do is talk to you about a different approach by investing a little bit of time now for future improvement. Okay, so what can you do? By focusing on productivity and sustainability, you can get better, faster, cheaper, pick all three. Okay? Maybe not today, but down the road. So let's take this scenario and go forward in time 6 months. So after investing in some developer productivity improvements, I'm going to tell you some of those, some ideas. You can have your own, of course. Now, because you're faster, you're better at doing your job, you can actually deliver this sophisticated model on time without losing sleep and submit that paper by investing in tools, processes, and practices that help you do your job better. That's productivity. Sustainability. 3 years later, after investing in sustainability improvements, you are on time developing several sophisticated models in your software for results coming in an upcoming paper, and again on time without losing sleep. And this is by investing today in things that don't necessarily pay off right away. Things like testing, documentation, integration. These are efforts that have payoff in the long term. But you, over a longer span of time, are more productive and your work is more sustainable. Okay, so those are the concepts that I want to talk about and how they might play out in our world. All right, you might ask, well, why now? Why not before? Why not? Well, certainly there were efforts in this area, but we are in a particular time in the history of computing, computational science, and the use of computing in science where I think it's particularly urgent. And you can go to the front page of the New York Times to see why. Because in our field today, science is heavily scrutinized. This is a couple years old, this article is, but there have been many studies after this. This is really the first big splash, at least that I saw, that put a negative light on science and the reproducibility of science results. We have not been under the spotlight as much in our area, fortunately so far, because I don't know that we do all that much better. So we should prepare. as we do that. So there's a heightened awareness that scientific reproducibility is questionable. And so we need to do something about that. We need to prepare ourselves so that our results can be reproducible. A second is, as you probably know, most of you, if you've been working on high-performance computing platforms, we're at a highly disruptive time in the computing field. We have our architectures changing underneath us. We're going from a nice, pleasant world of message passing, MPI only with sequential processing underneath, to now multi-core, many-core GPUs, and we're not done, right? We're going to see a large variety of architectures. Now, all of the focus in the press is about these new hardware devices that are coming out. And those are big changes, but the real issue is that a minor change in hardware leads to a large change in algorithm design and a large change in software design and implementation. So any small change in hardware has a disproportionate impact on the algorithms and software that we have to work with. And so these are actually the biggest challenges that we face. I will argue that the algorithms work, which is most of what we're doing actually, is the easy part of these big changes. Okay, why is that? Because we have whole infrastructures, we have institutions, funding agencies that are dedicated to providing funds and coming up with new ideas for new algorithms. And so we already have the infrastructure in place to rise to the challenge that new hardware provides. This new hardware we're getting challenges us to develop new algorithms, and we're actually doing really good work in this area. And so I'm actually quite confident that we will be good when these architectures become the thing that we use, that our algorithms will be ready for that. But the hard work is that we have billions of lines of code that produce solid science, solid engineering, that are not ready for this change in architecture. So we have to either transfer, refactor, or rewrite this software onto these new architectures. Okay, this software doesn't migrate itself. It has to be redone in some way in order to prepare for these new architectures. So to me, that says focusing on how we do our software, being productive in how we do it, designing it and implementing it so that it's sustainable is really critical. It's actually a major cost benefit opportunity we have, a benefit that we have if we can do this work better, be more productive, make it more sustainable. All right, so you say that, and then we say, well, but what about incentives? How can we make that possible? It turns out that just these facts alone are not enough. This information alone is not enough to get people to move in the right direction. So we actually have to create incentives. I often get this statement when people know now me as a productivity person. Okay, I don't necessarily like that label, but it works for me. Okay, I'll be whatever I have to be to help people get their job done right. They tell me, I would love to do a better job with my software. I'd love to learn new tools. I'd love to put in the time and effort to make it more sustainable, but I have to get this paper done. Right? I have to complete this project task. I have to submit this proposal. My funding agency doesn't care about this stuff. They care about other things more. My employer doesn't care about it. Okay, so how do we fix that? So we have to actually work to change the incentive systems in order to do that. And so to me, if I really want the community to focus on productivity and sustainability investments, then I need to change the incentives. I need to make reproducibility a higher priority. I need to make software quality requirements a higher priority. I need for people to be able to get recognition for when they do good work in software. And so if I can change these things, if I can improve the incentives for these three things, I can provide the demand for productivity and sustainability. And the virtuous circle is that improving productivity and sustainability enables the three things that I want to improve as well: reproducibility requirements and recognition. So they feed on each other in very positive ways. So let's talk a little bit about reproducibility. I was at a workshop I organized 2 days ago at NSF. Our community has this unfortunate situation that we have two competing taxonomies for reproducibility. And they each define reproducible and replicable, but they actually flip the the definitions. And so we're in this terrible state right now. We're in our community where we have these two competing taxonomies, and there's possibly a way forward as of Tuesday, so I'm hopeful. But I'm going to talk to you about the ACM taxonomy and talk with you specifically about replicable research. And ACM uses the term replicable to mean that someone else can use the software environment that the author used or the original researcher used and can produce that same result. So essentially they're checking the work of the author. I just recently retired as the editor-in-chief for ACM Transactions on Mass Software, and one of the things I did when I was the EIC was I instituted the Replicated Computational Results Initiative. Essentially what it is that we have a standard review process that, like any paper, right, to determine if it's a qualitative impact on the field. But then we also have an independent review, totally orthogonal to that looks at whether or not the computational results in the paper can be replicated, can be produced by somebody else. And so that process goes on at the same time as the standard review. And what does it do? It elevates the consequences associated with doing and producing good results. And in fact, the second paper that went through this process, I got this note from the author. To make this easier, we have preserved the exact copy of the code used for the results. That's exactly the behavior that we want, right? We want people to be careful in accounting exactly what they use to produce their computational results so that they themselves can go back and do the experiment again, or somebody else can do it and build upon their work. And so what we're trying to do with this effort, and now there are a number of other conferences that are doing this. And in fact, I was the tech paper chairs with Anne Benoit for SC17, and we're doing something there as well. So ACM has now several conferences that use this. There's actually about a dozen now that use it. Several of their journals, TOMS and TOMACs, and then a few more now that use it. And ACM has a badging process that gives you a badge. If you do good work for reproducibility, you get a badge applied to your paper, and that's high visibility. So we're trying to improve incentives for authors to invest the time it takes to make reproducible research. Just briefly about SC17. So if you've submitted it all to the supercomputing conference, you've seen that we've been increasing the opportunities for you to show your reproducible research. We have an artifact description appendix, which you describe the computing environment that you use to produce your result. We added a new one this year that is called the Computational Results Analysis Appendix, that allows you to describe what do you do in your execution of your code that better assures the trustworthiness of your results. For example, if there are conservation principles at play in your simulation, do you test those numerically? Can you take one of the volumes in your domain and test whether the flow and sources actually sum up to be conserved? Those kinds of things. These are extra computations you wouldn't have to do to get the result, but you do them to better assure that what you produce is what you thought you produced. This kind of approach is required in large-scale computing, boutique environments I call them, because you may never get a chance to rerun that computational experiment. You may not get enough time. The machine may change. It may fall apart because there was a bunch of FPGAs. Right? But so this approach, computational results analysis, is meant to focus on upstream activities and peri-execution time activities that better assure the trustworthiness of your results. So we have these two ways for you when you participate in the supercomputing conference papers to exhibit the effort that you put into reproducibility. And so I mentioned some of these sources. As I said, synthetic operators. You can, if you have a code and you can create a synthetic operator with known spectrum, known rank, you can put it through your code and test it. Does it really produce the spectrum or rank that you expect? Same thing for invariant subspaces. I mentioned conservation principles. And then in general, you can apply preconditions, postconditions, and invariants to test whether the code is computing what you think it's computing. Right? These kinds of things are really helpful. All right, so that's reproducibility. Software quality requirements. So another way that we can provide incentive for investing in productivity and sustainability is to look at funding agencies, right? And places where they can set expectations on the quality of your software. So I've been working with the Biological Environmental Research Office. I just met with them yesterday. and the OSCAR office, the Office of Advanced Scientific Computing Research, to put into funding opportunity announcements requests for descriptions of your software environment. What do you do to have productive and sustainable software? Okay, so request for information, but BER has actually used this now for a couple of years, and they say it really helps them see two proposals and know if someone is really serious about their software. And guess which one will get the money if it's close, right? The one that has a good software description. And so we're working with the offices to try to provide incentive. So now this is money attached to whether or not you do a good job with software. These are some of the requirements that go into it. We're very pleased that they've been able to use this effectively in their funding opportunity announcements. All right. The third one is, I said employer recognition, but really it's community recognition. So how do you get the community as a whole to value people who do good work in software, right? And so we're trying to work with various institutions. I'm coming to this meeting here to convince you that this is valuable, right? So that we can get the entire community thinking in this direction. Okay, you're getting started in your career. How will your future be different than what mine was as I started out many years ago? Well, I predict that publishers will expect reproducible computational results. I expect that funding agencies will expect improved productivity and sustainable software. You will have to prove that you are doing good work. And I expect that employers will reward people who do good work in software. And I see this already happening in all these areas, and I expect that this will grow and continue. And for me, the big benefit is an improvement in the high-quality CSE software, and it will matter a lot more. So now let's talk a little bit about productivity improvements in general. All right, so I have been in this field a long time, I said. At Krell, I experienced my first troubled interaction with software engineering experts. We were told as a group that we had to adopt the waterfall method, formal method. We were not ever asked about how we might find it useful, right? We were just told this is how we were going to do our job. Commercial techniques were just brought in and blindly applied to our work. We dutifully did it for a couple of months. We realized it wasn't helping us, and we went back to our old way of doing it. Same thing with DOE-ASCII in the early days. Now, this has evolved and is a very actually nice model, what DOE-ASCII does today. But in the early days, there was talk about CMMI level 3, very formal industrial methods applied to research software. And again, there was just a strong disconnect. And because what did these people fail to do? They failed to actually step into our environment, understand how we could actually be impacted positively by the work that they knew, right? They know how to do good quality software, but they didn't try to adapt it to our environments. And so this picture actually here of the lock, the keys are for the lock. Anyway, so it was meant to be a joke. And that's how we felt, right, at the time, right? We were given all these things, but we were burdened down by them, and so we couldn't actually get our work done. An attitude I much prefer is proposed by a book called Code Complete, Steve McConnell. If you want to follow an author, he's one of the thought leaders in the software industry whose ideas are really nicely applicable to computational science. So I strongly encourage you to follow him. Now, this is a pretty old book, and he's chose other media for conveying his new ideas, but even so, this book is really good. The focus of this book and his general attitude is that code is ultimately what matters. That is the true metric. But to produce the best code, most effective code, you really need to spend a significant amount of time not coding, right? And it's really important to do that, but it's hard to do, right? And I give you a few quotes from some famous people that also indicate the same kind of attitude. All right, so let's talk about one of the activities, this planning activity. Okay, so this is also adapted from a different material that Steve provides from his Software Project Survival Guide. Okay, so this is often what people in computational science do, right? Code is the ultimate metric. So what do I want to do right away when I start creating a computational tool? I start writing code, right? And I write and I see this great progress, and I feel so good about what I'm doing, okay? And then as I go along, I have to start doing a little planning because I have a code base. So I have to think, well, how would I integrate new features into my existing code base? Also, I have to, on the top of that graph, start recoding because I didn't really design my code. I just started writing it. And so now I have to go back and refactor, recode, import it to new platforms. And you can see what's happening as time goes on. That because I didn't really have a plan for what I was producing, the time I spend planning has to increase because I now have to think about how to inject stuff into it, and the amount of time I spent recoding also increases, and at some point, all my time would go into planning and recoding, and so that's when the project dies, right? This is actually, I've seen this happen more than one time. So we want to avoid this situation. So let me propose a modest change to what's going on here. What if you spent just a little bit of time up front, right, in your small code, a little bit of time only planning, okay? Get the requirements written down. Get some analysis done. Do a bit of design. Pass it around to your colleagues. Paper only, digital PDF files only, right? No software. Maybe you had to do a little bit of software work to test out an idea, but you're really focused on the design, writing something down that doesn't require software. Okay. This kind of effort can succeed because you have now written a design that has forward potential. And so you can spend less planning as you go along, you spend less time recoding, and then all that white part is progress, right? But you had to have a little discipline in order to do that, okay? Now, do you have to get into some fancy tools in order to do that? I argue no. Here's a simple plan that was developed by some of my colleagues in the Trilinos project, a package called Coco's Kernels. They were working on micro and batched BLAs, which are really important for many core, multi-core GPU type architectures, being able to execute lots of kernels at one time. All they did to improve the design is they wrote a LaTeX document. They wrote out their requirements. They did some analysis. They did some planning of how this computation could be implemented on a GPU or a KNL, a nice landing many-core processor. They passed the document around to their colleagues, and they actually found some fundamental design flaws from the experts who knew the architecture. So it took about 6 weeks to go through that, but then in 2 weeks they were actually able to write the code, and it was code they would not have written because they had the design wrong in the beginning. So what you do does not have to be fancy to get started. Okay. Now, if you're already beyond this, that's fine. But if you haven't done any of this kind of work, I'm trying to say to you that you can do simple things first and have a big impact on your work. You don't have to wait till some fancy formal process comes along that helps you to do it. Use the tools that you know. What's another productivity improvement? Issue tracking. Okay, so what I advocate to you here is not any particular issue tracking approach or tool, but that you start doing it if you haven't been doing it already. Okay, if you are right now, if someone asked you to do something in your piece of software, in your work in general, and you remember it in your head and then try to get it done, that's an issue tracking process. Not a very reliable one, at least not for me. Okay, so if you're doing that, I advise you to try this. Write a little ToDo.txt on your computer desktop, just for you, right? Type it in. Now you've got a list of things. You won't forget them. Okay, it won't be as accessible. It's on your desktop, but do it on your phone, in your notes, wherever, right? If you're a team, how about using a file called issues.txt? Put it in the root of your repository. Now everybody can see it. That's an improvement, okay? Now consider, if you're doing that already and you're comfortable with that, move on to something else. Start using GitHub Issues, Jira from Atlassian, Trello, right? Lots of tools out there that allow you to do collaborative issue management. And think about some kind of lightweight agile methodology to manage those issues. Two of the most popular are Kanban and Scrum. Scrum is probably it is by far the most popular lightweight agile methodology. I don't see it fitting really well in a research setting because we have too many interrupts that drive us. I like and prefer something called Kanban, and I'll talk about that next. All right, what's Kanban? So Kanban is a lightweight, agile workflow management methodology. That's a lot of big words packed into one. But basically, it's a way of managing the things that you have to do. Right? How do you manage that? How do you decide what to work on today? How do you decide what to work on next? How do you decide what to leave in the box and never maybe get done? Get rid of it, right? So the principle of Kanban is to limit the number of things that you have in flight at any one time. That is the discipline of Kanban. It says you can only be doing so many things at once. Okay? And if you want to do something else, you have to finish one of the things that you're working on. So you can't bring in a new thing until you finish one of the things that you're already doing. You can't set that thing aside and pull in one. You can't swap out until it's done. That's the discipline of Kanban. Okay? And so it's actually a really nice model for identifying impediments to progress. Because if you are wishing you could get onto something else and you can't, it forces you to think about what you're doing and not getting done. And it improves your productivity and your efficiency by forcing you to focus on that. And so I like Kanban. In fact, I run my life by Kanban. I have Trello on my phone, on my iPad, and in a web browser anytime I want it. And everything I do is managed on my Kanban board. Okay? I'm a little bit of a nut that way, but I'm happy to show you what I do. Okay? All right. So what's the basics of Kanban? Okay. Any issue, any task, anything that you want to do, put in your backlog. Okay? There's no restrictions on what goes in the backlog. Anything that is ready, meaning you know what you need to do and how you're going to get it done, can go in your ready column. Okay? That means it's ready to be worked on when you have a slot open to you. The in progress column is anything that you're working on. Okay? And the only rule of Kanban is you can have only so many of those things active at once, and that you cannot just pull one out if it's not done. Then the done column is everything you've completed. That's the basic set of lists. Okay? I have other lists. I have a list of things I won't do. Okay? I won't host a meeting that's more than 30 minutes long. I won't accept an invitation to a talk that I think somebody else could do a better job of on my team. These are really nice things. I like this. These are my personal promises to myself. I also have a quick to-do. These are things like 10 minutes long that if I have a little bit of time before dinner, I can sit down and do one of those things. So these are things that I've put in. You can put in interesting columns too. You can put in a column that's called Waiting on My Advisor. All right? It's really an interesting thing to do because the moment you're done with something, you can move it into that column and timestamp it. And guess what? How long it sits there is visible to everybody who has access to that board. All right? All right. So those are some ideas I wanted to share with you. I want to do just a few more things before we finish up. Okay. So let me give you just a few recommendations first, and then move on to some things that I'd like to get your help with. Okay, what's the first thing? Okay, this is a quote of me. Okay, I'm quoting myself. I don't know if you put your name under your own quote. Okay, but anyway, this is a quote of me. Show me a person who makes the most commits on an undisciplined software project, and I will show you the person, because it's the same person, who is injecting the most technical debt. Now, what is technical debt? Technical debt is work that got submitted and left and didn't have enough artifact, enough documentation, enough testing to really be sustainable and usable in the long term. And it ends up being that somebody has to go back and do that work again, or eventually it becomes unusable and you throw it away and you have to produce a new piece of code, right? So, show me the person who's doing the most commits on your project in an undisciplined project, okay? Now, and I will show you the person who's injecting the most technical debt. All right, so many of you use GitHub, I'm guessing. Who uses GitHub? Great, okay, so I hopefully most of this context is meaningful to you. So I know people who take a lot of pride in the number of commits that they make on GitHub, because it's the most visible statistic. If you go out to github.com and you look at a project, you look at a person's profile, the number of commits they do is a kind of badge of honor. Okay, well, that's all fine and good if the project is producing the other artifacts that are necessary for sustainable software, but it's not okay otherwise. So I'm going to offer to you other metrics that I think are more valuable if you want to pay attention to GitHub metrics. Okay, you can find these things out. You have to maybe do a bunch of searching and filtering of the list, but you can find these things out. I would suggest you become the person who writes more requirements, who analyzes and designs things, even if it's simple. Be the person who writes good commit or GitHub issues and tracks their progress to completion. You can get this data from GitHub. Be the person who comments on, tests, and accepts pull requests. Right? And be the person who does good wiki, GitHub pages, and responds to other issues. Okay, so I offer those as better metrics going forward if you want a truly productive and sustainable life in computational science. Okay, so some summaries and then some requests for help. Okay, CSE is not complete without incorporating better reproducibility, sustainability, and productivity. I hope I've given you some arguments for that today. Also, in the philosophy of completeness, we can't just blindly accept productivity improvements, right? You can't just take on something from the commercial software field and blindly apply it. We have to put some thought into how we do it. Why is that? Well, if you think about our domain, you are experts. You are acquiring or a PhD or have one or very close to one, and it's going to take you 5 to 10 years before you can be a truly competent scientific software developer. That's a lot of domain expertise, right? So it's hard for someone to be that good at something, in the domain, and then also become an expert in software engineering. So that's hard to do. Some people can do it, okay, but it's hard to do. But what's even harder is for a software engineer to come in and understand our domain. That is really, really hard, right? Because they don't have the PhD. They don't, in our domain, right? They don't have all those years of experiences. They don't understand the sensibilities of scientists as much, or the intricate interactions, or our strengths and weaknesses, right? We are a very peculiar group of people. I have to say it. I didn't say that's bad, but we are a peculiar group of people, right? And so they have to understand that. And so I find that it's better for us to learn about software engineering, work with these experts, and incorporate what they provide for us, assimilate it into our environment, than to blindly take what they give us. As I said, victim's probably too strong a word, but at Cray in the early days of the ASCII program, I felt like that did not happen, and I want to do it differently. Okay, and then for you, your career, you can expect that publishers, funders, and employers will expect more from you, and that will result in more demands for productive and sustainable software. All right, so 2 things I want your help with. We have a new project, a new web portal we're developing called Better Scientific Software. All right, we're in the process of creating content for that site. And guess where we're doing it? It's actually a really cool architecture. We're doing most of the content development on GitHub. So we write markdown files, we take pull requests, we iterate, we create issues, and we have style guides, contributing .md files, right? Everything that you care about and can use on GitHub. We're using GitHub to its full potential to produce content. And then that content is sucked into a formal Ruby on Rails environment for polishing and prettying and creating dialogues and comment boxes and all that kind of thing. We would love for you to help us with that. If you have an idea for an article, or even if you just want to go out and see what we're producing already, please get involved. Ask me if you have a good idea. There's a whole process, a simple, lightweight process for suggesting ideas. Go out there and take a look. Okay, and you can look there by getting started on the readme.md file, or you can just type in GitHub Better Scientific Software and you should find it pretty quickly. Okay, so please, help us if you have interest in this particular area. The last thing I want to mention to you before I stop is when I got started on this about 1.5 years ago or 2 years ago, I wanted a way to really reach out to each person individually on my teams, right? To put in front of them something they could look at every day. And so I created magnets, okay? Shelf magnets. And they have this on. And actually, this is version 1.3. I versioned these, right? Good practice, right? Version 1.0 I had to throw away because there was a printing error. Version 1.1 was pretty good. But then I realized, if I put a QR code, it actually could bring you right to the web page. So that was version 1.2, but that was a little fuzzy. And so then I redid version 1. So 1.3 is the most recent version. It's pretty stable. Okay, but the content hasn't changed. And what is on here? So I want you, when you sit down to your desk, I want this in front, right to the side of your screen. Okay, and I want you to ask yourself, after you've had coffee, you've chatted with somebody for a while, I want you to sit down and ask, I'm going to do my work right now, and I'm going to say, is it traceable? Can I trace the work I'm going to do back to something that is really important, that's something I fundamentally care about? If it's not, don't do it. Do something else. Is the work in progress? In other words, is it in my Kanban column that's in progress, that I'm supposed to be working on? Or did somebody call me and ask me to do them a special favor and now they've distracted me? Okay, ask yourself that question. Is it sustainable? Have I put in the amount of extra effort so that the software product I'm working on is going to live long enough, that as long as I expect it to live? And then the last thing is improved. Have I done something recently in the past month? Have I watched a blog or read a blog or listened to a podcast that helps me do my job better? You should be doing that on a regular basis. I want my developers to do those 4 things when they sit down to their screen and do their work. And I have not as many as I'd like. I should have brought more, but I do have a few. If anybody wants one, you can have one. They stick really nicely. I also have more. And so if you didn't get one and you want one, send me a message and I'm happy to mail one to you. I had a very kind, thoughtful student send me a pre-addressed stamped envelope in the mail asking me for one of these. I gave him 2. All right, and then I give my acknowledgments to my employer, in particular Sandia National Lab, who sponsored this trip. So thank you for your time and attention.